All right, this is lesson 5.6, which is graphing inequalities in slope-intercept form. And so we have this checklist for us to go through. These are questions that you should be asking and answering in your head while you're doing this problem, okay? So here's what we're going to do first. First, we're going to graph this as if it's a line, but we're only going to plot the points. So first, the y-intercept at -5. Then we'll count our slope of rise of 3, run of 1. I'll go ahead and connect. No, I'm not going to connect the points yet, right? Because I have to ask myself some questions. First question, can y equal the line of solutions? So if you look here, this says just y is strictly less than the solutions. Okay, and so since it's just less than, that means no, you're not including the line. And so we're going to draw a dashed line instead of a solid line. Not a solid line, you're going to dash it as you draw it. This shows that the line is not included in the solutions. Okay? What I might do is, as I get good at this, I'd write dashed right here. The next question says, is y greater than the line or less than the line? So this says y is less than the line. So we'll shade the y values that are less than the line. So what you do is you go to your y-intercept, and the y values that are less than the line are below the line. So you shade down from the line. Everything over here is shaded. All of these values are less than the line. The last thing says to test a point from the solution area to ensure it's a solution. So I can grab any point over here. Let's say, I don't know, like this point here, 1, 2, 3, 4, 5, 1. And I'm going to test it to make sure that it's true because it's in the solution area. So 1 is less than 3 times 5 minus 5. 1 is less than 15 minus 5. 1 is less than 10. 1 is in fact less than 10. So this is a solution. Let's go ahead and do example 2, also using the checklist. So first, I'm just going to plot the points. Y-intercept of 4, slope of -2 over +3. Down 2, right 3. Down 2, right 3. Down 2, right 3. And I'm not going to draw my line yet. I'm going to ask myself some questions. All of these questions have to do with this symbol. So, can y equal the line? This says greater than or equal to, so that's a yes, which means we include the line. It will be solid. A solid line shows that it is included. Solid line. Now it says, is y greater than the line or less than the line? This says y is greater than the line. So I'll go to my y-intercept and I'll shade things that are greater than the line. Next, I'm going to test a point that's in the solution area. Again, I can test any point I want, like for example, this point here. 1, 2, 3, 4, 5, 6, 2. So I'll test the point 6, 2. I'll just go ahead and substitute those in. Times 6 plus 4. This was a smart value to choose because I can in fact reduce this. So 2 is less than or equal to negative 4 plus 4. And so 2 is greater than or equal to 0. There's also smarter values to choose because notice that this is a fraction. A smarter value to choose is one of these that are just actually on the y-axis because it would in fact be, it would get rid of the fraction. 4, 5, 6, 7. So if I were to instead choose a 0.07, then when I substitute that in, 0 for x, it's actually going to get rid of this fraction. Anything times 0 is 0. So 7 is greater than or equal to 4. Again, these are smarter choices. I'll go ahead and do the next two just so that you can get some more practice, but I'm going to say the checklist out loud. This says graph the inequality. So first I'll plot the point for my line, but I won't actually graph it. Slope is 1 over 2, rise 1, run 2. Now I'm going to ask myself some questions regarding this sign. This says y is greater than the line, so does it equal the line? No, so it's dashed. Because the line is not included in the solution. Next, I'm going to ask myself, is y greater than the line or less than the line? This says greater than, so I shade every y value that is greater than this one. So I'll shade up. These are all the y values that are greater than the line. I'm going to test a point. A very easy point you can test when you can is 0, 0. Is 0 greater than 1/2 times 0 minus 5? Is 0 greater than negative 5? Yes, so that is in fact a solution. Number 4, first plot the points, y-intercept of 7. Slope is negative 4 over positive 1, so down 4. 1, 2, 3, 4, right 1. Next, ask myself some questions about this. Can y equal the line? Yes, so it's solid. Because the line is included in the solution. Then y is less than the line, so I'll shade all the y values from my y-intercept that are less than the line. So below the line. Lastly, test a point. I have 0, 0, so I can go ahead and test that. It's an easy one. 0 is less than or equal to 0 plus 7. Is 0 less than or equal to 7? It is, so we shaded the correct side.